Okay, guys, so we're in our unit on polynomial and rational functions and expressions, and one of the things we want to make sure we can do is divide one polynomial into another polynomial. So as we get started, I thought it might be nice just to review a little division vocabulary for you. What you're dividing by is called your divisor. What you're dividing into is called your dividend. And then our answer is going to be our quotient. So we're trying to figure out the quotient for this problem. We're going to go through two different division processes. We're going to do long division first, and then we're going to do a good bit of a shortcut called synthetic division that I know you guys have learned before. So I'm going to do two with you. You guys will do the other two by yourself, and then I'll do one of the synthetic division problems for you as well. So let's just jump right into number one. We're going to divide 2x minus 3 into this larger polynomial here. So I'm going to take 2x minus 3 into 8x cubed minus 18x squared plus 21x minus 20. When I use long division, I'm going to always start with my leading term for my divisor and divide it into my leading term for my dividend. So my 2x is going to go into 8x cubed, a complete 4x squared times. Okay? So now I'm going to distribute this into these two terms here. So when I distribute it, I'm going to end up with 8x cubed, which shouldn't be a surprise because that's how we set it up to be. And then we'll multiply here and we'll have a minus 12x squared. So once I do that, I'm going to subtract what I have here away because this is what we've kind of already used up when we divided the 2x into the 8x cubed, or we divided this divisor into these first couple of terms. So when I subtract this away, I end up with a 0 here. Then I have negative 18x squared minus a negative 12x squared, so we're really adding 12x squared. So I have a negative 6x squared left over, okay? Once we've done that, we're now going to drop this term here. This is two terms, so it's going to subtract away from two terms when I end up distributing. So I have a plus 21x here. And then we're going to start over again. We're going to say how many times does 2x go completely into negative 6x squared? Well, negative 3x times. Then we'll distribute again. So that's going to give me a negative 6x squared. When I multiply this by this, I multiply this by this, and I get a plus 9x. And then I'm going to subtract what I have. So I have a negative 6x squared plus 6x squared, that's 0, and a 21x minus 9x, which will give me 12x. I'm going to do this again. I drop my negative 20. And then I'm going to say, can I take 2x into 12x? Well, yes, I can. It goes in 6 times. I distribute. And again, I'm distributing this 6 times my divisor, which will give me 12x minus 18. I subtract what I've used up. That becomes 0. Negative 20 minus a negative 18 will give me, so negative 20 plus 18 will be negative 2. So then I would do the process again. I'd say how many times does 2x go into negative 2, but it doesn't go any complete times in. So this is I'm kind of done with my long division process. This is going to be my remainder. And the way I write that is I do minus, because this was negative, 2 over my divisor. We're saying once I went through and divided this into all my terms, I had this negative 2 left over. It never really got divided by this 2x plus 3, so that's why I write it like that. So this is my quotient, and this is the answer to this first problem. So I'm actually going to write it out and box it, because it's my final answer. And I don't have room at the top to put a box there cleanly. So for this problem, we divided something that was linear into something that was cubic. We're going to actually skip down to number 4 now, and we're going to take something that's quadratic into something that's something quartic. Now, something that's a little bit different about number 4 is the divisor, the thing that I'm dividing into this numerator, is actually missing a term. This is a quadratic. We've got my 3x squared term, but there's no x term, and then minus 2, that's my constant. So one of the things that I recommend doing when either your numerator or denominator, or either your dividend or divider is missing a term, put in a placeholder for it with just 0x or whatever. It needs to be 0x squared, 0x cubed, whatever. So let's write this out. We're going to have a 3x squared. A lot of you guys might not need to or feel like you need to put the placeholder in. Oftentimes I don't, but I will for today just to show you what that's going to look like. So now I have a placeholder for that x term. And this is going to go into that 6x to the 4th minus 4x cubed plus 3x squared plus 12x minus 5. Got a little slanty there. Okay, same thing. I'm going to take my leading term into my leading term. I'm going to go in 2x squared times Now I'm going to distribute that. That's going to give me 6x to the 4th times 0, so that's just going to be 0. So you could put a 0 term here if you wanted, or sometimes I just leave that blank if I don't use the placeholder. And then we'll have a minus 4x squared. So now I subtract. 0 minus 4x cubed. We've got a rolling pen. I'm subtracting for a negative 4x squared, so I'm really adding 4x squared, so I've got 7x squared. And then because I have these 3 terms here, because it's a quadratic, I'm going to drop this down, so I now have a third term. Now we go again. How many times does 3x squared go into my leading term of negative 4x cubed? Well, remember, I'm dividing this into this. So the x terms are easier. I'm going to have x cubed over x squared, which is x. But now I have negative 4 divided by 3, and that doesn't go in evenly, so we're just going to leave it as negative 4/3 x. So now I'm going to distribute. I multiply this out, so 4/3 times 3 will be 4. X times x squared will be x cubed, so negative 4x cubed. Let's do this again. So now we're going to multiply by that 0 term. Well, that's going to be 0. You could put 0 or 0x squared. Now I distribute to this negative 2. That's going to give me a positive 8/3 x. Okay. So remember, now I'm going to subtract this all away. That's going to give me 0. This will just be 7x squared again. Now this is a little bit grosser. I have 12x minus 8/3 x. Well, this 12 could be rewritten as 36/3 if I want a common denominator. So if I wanted to, remember, I could really think about this thing here as 36 over 3x. I just got a common denominator of 3. So now when I subtract that 8/3, I have 36 minus 8. So I'll have plus 28 over 3x. Okay. So now again, I'm gonna go through my process again. I'm gonna drop down my 5. I'm gonna take 3x squared into 7x squared. Well, that x squared goes into x squared perfectly one time, and then I have 7 divided by 3. So really what I have here is a 7/3. When I distribute this to this, I'll become a 7x squared. When I distribute to this, that's gonna be a 0 for my x term. And then when I distribute here, I'll have a negative 14 over 3. So now I go through and do my subtracting. That will become 0. That will become 28 over 3x. Now remember, this minus 5 here, if I get a common denominator, it'll be easier to deal with. So I'm going to just rewrite this as 15/3. That looks kind of messy already again. So if I have 15/3 minus, hold up, make sure I didn't mess something up here. Minus 14/3. Oh, right, this is a negative 15/3 minus a negative 14/3. So really what I have is a negative 15/3 plus 14/3. That's going to leave me with a negative 1/3. So this is my remainder. It's kind of gross, but let's write out my quotient because they asked us to rewrite this using long division. So we have 2x squared minus 4/3 x plus 7/3. And then I have all this gross stuff left over. I'm not going to simplify this. I'm going to leave this gross as fractions and fractions, which isn't ideal, but for right now, that's not what I'm most concerned about. Goodness gracious. Here's my answer. So this all came from here. This was my remainder, and then I put it over because this never got divided into this, so that's my remainder term. So one thing I think that's worth pointing out is this expression here is mathematically equivalent to this expression here. It's rewritten. When you think about it, if I have something to the 4th divided by something squared, my resulting answer should be something squared as the leading term, which is what I have. So when we get to calculus, the main reason we actually do long division is to rewrite it into something that's more useful to us, but we'll get into that next year when you guys are in calculus. So that's long division, a review of long division. You guys are going to do 2 and 3 by yourself. So what I would probably do is pause this video now, go ahead and do problems 2 and 3. And then when you're ready, you can resume with me, and I'm not going to do one of the synthetic division problems. So when you're ready, you can pause and start doing some problems for long division. Okay, so hopefully you've had a chance now to do those 2 long division problems and check your answer. We're going to jump into synthetic division, which is a shortcut for long division. It's very handy. So I don't know which one I want to do. Why don't we do this one here? So we're going to use synthetic division. This works when you're dividing by a linear factor. So why don't we highlight that so we don't forget. So it's a shortcut, but it only works when you're dividing by a linear factor. So that's something that's going to be in the form of y equals mx plus b. And you'll notice this is, my slope is 1, my b is -1 here. So when we use synthetic division, we're going to look for the 0 of the denominator, so that 0 is going to be 1. And then we're going to set up kind of looks like a box. So before I do that, I notice that this is not written in standard form. The x cubed term isn't first. And when we do synthetic division, we're going to actually write out all of the coefficients. So my largest term is the x cubed term, and its coefficient is 1. My x squared term has a coefficient of 5. My x term has a coefficient of 8. And notice there's no constant term, which means it has a value of 0. You need to make sure you use a placeholder of 0 for any term that's missing. So if I'm starting with x cubed, I should have something for x squared, x, and then also for my constant, which in this case is 0. Okay, so the way synthetic division is going to work, or the process, if it's been a while, is we drop this first term, it's 1, and then we multiply by this term in the box. So 1 times 1 is going to give me 1. Then I'm going to add these together, I get 6. I multiply these together and I get 6. So it's a lot of multiplying and adding. If I add these together, I get 14. By 1, I get 14. And then I add. Okay? This is my remainder. This is my leftover. When this is 0, that means that this term went into this perfectly, or like a whole number of times, but we have a remainder. This is going to give me my resulting polynomial. You'll notice that I started with something cubed and we divided by something that's to the first degree, so I'm going to be left with something to the second degree. So this is actually going to be my coefficient for my my x squared term. So I'm going to have 1 x squared plus 6x plus 14 plus my remainder, which is going to be 14 over what I divided by, which 1. So this is, as you can tell, a lot simpler of a process than using long division. And it will give me my resulting quotient, which is just, this is mathematically equivalent. So there you go. See if you guys can do number 5 by yourself, and then you guys can move on to the next video.